5 days ago, a Chinese spacecraft orbiting Mars caught a brief, rare glimpse of something that has been racing through our solar system for over a year. An object that formed around a different star entirely, possibly billions of years before our own sun existed. Now passing through our cosmic neighborhood on a path that will never bring it back. It's called 3I Atlas, and it's only the third confirmed interstellar object ever detected entering our solar system. By the end of this video, you'll understand why some of the world's most credentialed scientists still can't fully agree on what exactly it is. The discovery happened on July 1st, 2025, when the NASA-funded Atlas survey, the Asteroid Terrestrial Impact Last Alert System, based in Rio Hurtado, Chile, spotted a faint, fast-moving object roughly 410 million miles from the Sun, well within the orbit of Jupiter. At first glance, it looked like it could have been just another routine discovery, perhaps an unremarkable asteroid. Its motion immediately proved otherwise. The object was traveling on a hyperbolic trajectory, meaning it wasn't gravitationally bound to our Sun at all, unlike every planet, asteroid and comet native to our own solar system. It had come from somewhere else entirely, and it was only ever passing through. Astronomers later traced pre-discovery observations back to June 14, 2025, gathered retroactively from archives of other telescopes, including Caltech's Zwicky Transient Facility, extending our knowledge of its path even further back than the official discovery date. That made it just the third object of its kind ever confirmed, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. The naming convention explains itself once you know it. The number marks the order of discovery. The I stands for interstellar, and Atlas credits the survey that found it. Early estimates place the size of its icy nucleus somewhere between roughly 1,000 feet and 3.5 miles across, based on initial Hubble Space Telescope observations. An unusually wide range that reflects just how difficult it is to separate a small solid nucleus from the much brighter cloud of gas and dust, called a coma, surrounding it. As more data came in through late 2025 and early 2026, astronomers refined that estimate, eventually separating the faint glow of the solid nucleus from the much brighter surrounding coma using post-perihelion observations. The refined figure landed at an effective diameter of about 2.6 kilometers, making 3I Atlas considerably larger and more massive than 2I/Borisov, the interstellar object before it, and confirming this as a substantial body, not a fragment or piece of debris. Here's a detail that puts this object in a category almost nothing else in astronomy occupies. Some analysis suggests 3I Atlas likely originated from the Milky Way's galactic thick disk, during a period of intense star formation astronomers sometimes call cosmic noon, roughly 9 to 13 billion years ago. If that estimate holds up, this object could genuinely be older than our own solar system, which is a comparatively young 4.6 billion years old, meaning this comet may have already been drifting silently between stars for billions of years before Earth, or even the Sun itself, ever existed. Astronomers have no way to trace it back to whatever star system it actually formed in. That star may have already burned out, or may not even exist anymore in any recognizable form, leaving 3I Atlas as essentially the only surviving physical witness to a stellar neighborhood that vanished long before humanity, or possibly even our own galaxy's spiral structure, took its current shape. When 3I Atlas was first discovered, it was moving at roughly 137,000 miles per hour, pulled inward by the Sun's gravity. That speed increased to around 153,000 miles per hour at its closest approach to the Sun, known as perihelion, which occurred on October 29, 2025. Once it swings back outward, it will leave at essentially the same speed it arrived with, meaning nothing about its passage through our solar system meaningfully changed its trajectory. It came in as an interstellar visitor, and it's leaving as one too, permanently, never to return. Because an opportunity like this is so rare, an extraordinary number of NASA and international assets turned their attention toward it. Hubble, the James Webb Space Telescope, the Parker Solar Probe, using its WISPR instrument during a window when the comet was hidden from Earth by solar glare. The Europa Clipper spacecraft, which happened to capture rare ultraviolet observations while Earth-based telescopes were blinded by the sun. Instruments on the MAVEN spacecraft at Mars recorded the halo of gas and dust surrounding it. The SPHEREX mission examined the infrared light emitted by its dust, water, and organic molecules. NASA's TESS telescope, normally used to hunt for exoplanets, was redirected during a special observation run specifically to study the comet's activity and rotation. Even the ESA and NASA's SOHO Solar Observatory caught a glimpse as it passed near the Sun. This is very likely the most thoroughly observed interstellar object in the history of astronomy, largely because so many existing missions happen to already be positioned, by coincidence of timing and location, to look in exactly the right direction. What all that observation revealed only deepened the mystery, at least chemically. In December 2025, the James Webb Space Telescope made a significant discovery: a robust detection of methane in the object's coma, a genuinely volatile ice that only sublimates, meaning it turns directly from solid to gas at extremely low temperatures. Then, in a study published in Nature Astronomy in April of 2026, a research team led by Carreño used the Atacama Large Millimeter Array, or ALMA in Chile, to precisely measure the ratio between ordinary water and a heavier variant called deuterated water in the comet's coma. The result: 3I Atlas contains roughly 30 times the proportion of this heavy water found in comets that actually formed inside our own solar system. Carreño described the significance simply: every interstellar comet carries a small piece of its own history, its own fossils, from somewhere we don't fully know. And instruments like ALMA let us start to understand the conditions of that distant place well enough to compare it to our own solar system's formation. Now here's where the story splits into genuine, ongoing scientific disagreement. And it's worth presenting fairly, because credentialed experts land on different sides of it. Harvard astrophysicist Avi Loeb, previously well known for proposing that Oumuamua, the very first interstellar object ever discovered back in 2017, might have been an artificial probe rather than a natural object, has argued that 3I Atlas shows a cluster of anomalies worth taking seriously as evidence of possible artificial origin. His 2017 Oumuamua hypothesis, later expanded into a popular book called Extraterrestrial, made him a household name in this specific corner of astrophysics, celebrated by some for pushing the boundaries of what mainstream science is willing to seriously investigate, and criticized by others for blurring the line between rigorous inquiry and public speculation. Whatever position anyone takes on his specific claims, even his critics generally acknowledge that his provocations have kept public interest in interstellar objects unusually high. For 3I Atlas specifically, Loeb has pointed to an unusual antitail pointing toward the Sun, unexplained non-gravitational acceleration in its trajectory, and has calculated that if the object's movement were explained by ordinary ice sublimation alone, the required jet surface area would need to be larger than the island of Manhattan, which he argues is physically implausible for an object this size. He has also pointed to a bright glow captured in a Hubble image from July 21st, floating the possibility that the object could even be some kind of nuclear-powered technology. At one point, Loeb publicly urged people to take vacations before October 29, a comment widely interpreted as implying NASA might be withholding critical information, which briefly sent speculation across social media into overdrive before more data became available, and the comment's urgency faded. Loeb's underlying position is that dismissing these anomalies too quickly, without pursuing every possible explanation, including non-natural ones, risks limiting scientific inquiry itself. The broader scientific community, including NASA, has taken a different position. NASA Associate Administrator Nicola Fox described 3I Atlas simply as our friendly solar system visitor. Mainstream research teams argue that its behavior, overall, matches what's expected of a natural comet extremely well. A genuine coma, an actual tail, non-gravitational acceleration, consistent with ordinary outgassing, and an overall composition dominated by carbon dioxide, methane, and water. Exactly the kind of chemistry astronomers expect from a genuinely ancient, icy body. One astronomer summarized the mainstream comparison memorably. Comets, like cats, have tails, and they behave precisely however they want. An acknowledgement that comets are naturally unpredictable and strange-looking, without needing an artificial explanation for every anomaly. As of now, there is essentially no formal, peer-reviewed literature that substantively supports the artificial origin hypothesis. The scientific back-and-forth has played out mostly through preprints, interviews, and public commentary rather than competing journal papers, meaning the debate remains real and ongoing, but not yet settled through the normal peer review process science typically relies on to resolve genuine disagreements. Adding another layer to the investigation, the SETI Institute pointed its Allen telescope array at 3I Atlas in June of 2026, scanning a wide range of radio frequencies, specifically for any signs of technological signals. They found none, a result consistent with everything else astronomers have observed about the object's natural, comet-like composition and behavior. It's worth being clear about where this leaves things. Loeb's hypothesis remains a minority position within the scientific community, not something dismissed without engagement, but also not something that has produced a peer-reviewed body of evidence supporting it. The overwhelming weight of direct chemical and behavioral evidence, gathered from an unusually large fleet of spacecraft and telescopes, points toward a natural, if genuinely unusual, interstellar comet. Whichever side of that debate you find more convincing, there's something remarkable that both sides would agree on completely. This is direct physical material from outside our solar system, passing through our cosmic backyard for the only time it ever will. Chemically distinct enough from anything native to our own solar system that studying it means studying the literal ingredients of a planetary system that isn't our own, formed under conditions no laboratory on Earth could ever replicate. 5 days ago, a spacecraft built by one space agency caught a brief glimpse of an object that may be older than the Sun itself, on its way toward a Jupiter flyby in the months ahead, and then out of our solar system forever, carrying whatever remains of its chemical secrets with it, unlikely to ever be studied this closely again. We got a good look at it, and soon, for the rest of human history, we won't get another one at least not of this specific traveler. Whether the next interstellar object to pass through turns out to be number 4 in an already strange lineage, or whether it takes decades before another one is even detected. 3I Atlas has already changed how seriously astronomers take the search for objects like it. Beyond the visible, beyond what you can see, but never beyond what you can understand. Subscribe and check out the rest of the channel, new episodes on space, physics, and the edges of what we understand, going up every day.